Okay, so let's say you guys are simplifying radicals. First, what is a radical? A radical is a symbol for finding a root of a number. In this instance, I have a radical without a number associated with it. So we kind of getting the idea of a square root. Square root. And a square root is looking at a certain number, let's say 9, and saying to yourself, what number times itself would give you 9? So that's a 3. 3 times 3 would give you 9. And what you're doing is you're looking at it from a square perspective, meaning like, how could I make a square out of 9 pieces? I can make it out of a 3 and a 3. Now you can also use a variable when you're working with square roots. Let's say you have x squared. The square root of x squared is what variable times itself will give you x squared. That'd be x. So the answer to this would be x. Answer to this here would be 3. Now if I had x to the 6th, basically what I'm saying is x to the 6th to the second, like x to the 6 over 2 power. So basically I'm dividing this number by this number and saying, well, x to the third would give me x to the 6th, because when I multiply variables with exponents, I'm adding the exponents and I get x to the 6th. Now let's look at a couple examples. Let's say you get an example where you have a fraction form, like a 9 over 64. Well, you could just look at this like a square root of 9 over a square root of 64 and say the answer to this would be 3 over 8. Again, we're just working with numbers and radicals here. But let's say you end up with a number that's not a perfect square, like 300. Now we could work with 3 and 8 because we could take the number 9 and make a square out of it, like we did here. Right? We made a square out of this. I can't make a perfect square out of 300. So what you have to do is simplify it. Now, there's more than one way to simplify a radical. Let's say you're looking at 300. Okay? I can simplify 300, say, okay, I know by using its multiples, like 30, and 10. Square root of 30 times square root of 10 will give me 300. So I'm simplifying this. Now I could say square root of 2 and square root of 5 give me 10. I could say square root of 10 and square root of 3 give me 30 here. So I'm simplifying even further. Okay, and then I could say square root of 2, square root of 5 give me 10. So here I've made it what they call basically a factor tree. Now one rule you have to know is that any time a radical repeats itself, basically it's becoming that number, because square root of 2 times square root of 2 is square root of 4, and square root of 4 is 2. So since these two radicals repeat themselves, that basically becomes a 2. So basically this simplifies to a 2, and the same thing happens with the 5 and the 5. They repeat itself. Say again? The bigger the number, technically the more you have to simplify, yeah. I mean, it'll have more factors, more multiples. So here I have the 5 and 5 repeating itself. So actually square root of 5, so because square root of 5 times square root of 5 gives me square root of 25, which is 5, this is also going to become a 5 here. Now I can't factor the 3 here because it's a prime number. So actually I'm just left with the square root of 3 here. Now I'll multiply the 2 times and the 2 and the 5 and get a 10 square root of 3. And this would be the simplified answer for square root of 300. Because 10 times 10 is 100, 100 times 3 is 300. Now, is that the only way I could break down a 300? Absolutely not. There's a lot of different multiples for 300. So I could actually use two totally different numbers, like a 2. Anytime you have an even number, you know you could break it down with a 2. The 2 and the 150. Okay, and the 150 I could break down to a 75 and a 2. And the 75 I could break down to a square root of 25 and a 3. Now here's a couple things that happen. Well, again, we have the repeating square root of 2, which gives me the 2. Something a little different here, I end up simplifying to a perfect square, meaning I can make a perfect square out of 25 pieces using a 5 by 5 side here. So square root of 25 will simplify to a 5, and I'm left with a 3. And if you see, I end up with the same answer, 10 square root of 3. But let's say you guys are you're presented with a problem that has letters involved with it. So maybe I give you 75 x to the third. Go ahead.
What if you not just added this 2? What if you have 3
Well, then the other two would, so let's say your factor tree looks like this, okay? And maybe you have a square root of 3 here. Then I would just say, okay, these repeat, so I end up with the 2 here. These are both prime numbers, there's no repeat, so I actually end up with square root of 2, square root of 3. And because these are both prime, I would basically multiply these together to make it 2 square root of 6. That's a very good question there, because it actually gives us the idea of, okay, if I factor down to a certain amount of radicals and it doesn't help me go any further, I'll actually, let's say, recombine them. Now, here, what I want to do is I want to do two separate things. I want to look at the 75 to a 3 and a 25, which we just did. We just saw that. And get a 5 and a square root of 3. I also need to look at the letters here. Now, like I said, square root of x3, basically 3 divided by 2 is 1 with a remainder of 1. So basically I end up with an x1 here, and because I have a remainder, I end up with a 1 still in the radical box. The square root of y squared, well, 2 divided by 2 is 1, so I just end up with the 1 on the outside. And this is how I would simplify when dealing with variables. But let's say you end up with a question that has bigger variable numbers, like x9, y10, and let's use a z6, let's use a w7. And I'm trying to simplify these variables as a radical. Well, 9 divided by 2 is 4 with a remainder of 1. Basically, you always end up with a 1, x to a power of 1 in here, or a variable to a power of 1. 10 divided by 2 is 5, so I end up with a 5 here. And there, because this is divided evenly, I will not have a y left in here anymore. 6 divided by 2 is 3. And then 7 divided by 2 is 3 with a remainder of 1, so I'll actually be left with a w inside the radical there.